All right, here we are on week 3, day 3, minute 11. It says number 1, circle the number with a 4 in the thousands place, not thousandths, thousands. So I'm just going to do quick, it's ones, tens, hundreds. Then we change the period, which is the next group, which is the thousands. Then we have 10,000s. And then we have 100,000s. And it goes on from there. But it says circle the number with a 4 in the thousands place. So we need to have a number with the least a number with 4 numbers in it. And no decimal. The decimal would be here. So that's 300, 400, 4,000. So 4,000. Which of these shapes is a hexagon? And so if you're looking for a hexagon, you're looking for 6-sided shapes. So this is 4-sided. This is a pentagon with 5 sides. This is technically a quadrilateral or a parallelogram. So this is 4 sides. And this is 6 sides. 1, 2, 3, 4, 5, 6. So D is our hexagon. Which of the following is not equal to 40? So this is order of operations, probably the most commonly missed problems on the state test. You multiply and divide and then add and subtract from left to right. So we're going to 4 times 8 is 32 plus 8 equals 40. So it says which one is not equal. So this one is, so that's not the answer. 2 times 2 is 4 and 4 times 5 is 20. So this one is not. So we can circle B. I don't know if there's more that are not, but let's check. So this right here is a good example. When you see 2 numbers together in parentheses, that means that you're multiplying. This is equal to 5 times 6. So 5 times 6 is 30, and 30 plus 10 is 40. So this problem equals 40. So this is not it. So B is the only answer. Okay, this one's tricky, I'm not going to lie. Put the fractions in order from least to greatest. The good news is these have a common denominator. So you're looking for the smallest number on top because we want least to greatest. So we want, as long as the denominators are the same, you can put them in order. If they're not the same, you have to fix that so they have a common denominator. These have a common denominator, 8, 8, 8, and 8. Now we're looking at the numerator, 3, 7, 2, and 8. So I'm actually going to just do the fractions, the 8's are all on the bottom. And now I'm going to put them in order. Which one's the smallest number on top? So least again first. So 2, and then I'm going to cross it off. 3, 7, and 8. And 8/8 is the whole. Okay. Now this looks like a fraction, but this is actually division. If 42 over x equals 7, then x equals what? Well, how many times does 7 go into 42? 7, we count by sevens. This is why I like division so much more than multiplication, because they give you a range where you're going to get to. So 7, 14, 21, 28, 35, 42, 49. Okay, and I got to 42 already, so I'm going to stop. So I circle this. So I counted by sevens to 42. And how many times did I do it? 1, 2, 3, 4, 5, 6. X equals 6. Now, if you're really good with your math facts and you don't have to show your work and you just know that 7 times 6 is 42, I understand why you would just write 6. Okay, next, complete the pattern. So we're looking for increase in numbers. So 2 to 15, we add 3. 15 to 7, we add 2. 7 to 20, we add 17 to 20, we add 3. 20 to 22, we add 2. 22 to 25, we add 3. Now we're going to add 2. 25 plus 2 equals 27. Next one would be plus 3, which would be 30. And you could go on forever. I actually liked this kind of math when I was a kid. It's like, oh, good, number patterns. I love that. Okay. You only have to write 27. I think that's the only answer they give you in the answer key. How many cubes would 3 layers of this shape have? So if we had, this is 1 layer, if we had 2 layers and 3 layers. So if 1 layer has 1, 2, 3, 4, 2 layers would be times 2, because there's 4 here. So another group would be 2 times 2 is 4, 2 times 4 is 8, 3 times 4, because there's 4 in every layer, is 12. According to the graph to the right, and it doesn't tell us what this is, so that's actually really lame, because why else would you want to know this? A is going to show us, let's pretend this is dollars. Ooh, let's do Christmas money. Okay, so an A is a kid, B is a kid, and C is a kid. So how much did A get for Christmas money? A got 20, B got 25, and C got a whopping 45. It's probably a teenager. They tend to get a little bit more cash than the little kids, because the little kids like presents, at least from family members anyway. All right, number 9. These are just math facts. Sometimes I look to see if there's any common numbers, and I don't really see something that's the same. So I am going to just go with what I know. Now I can count by 7 9 times, or I can count by 9 7 times. I'm going to do my 9s because I know my 9's really easy. 9, 18, 27, 36, 45, 54, 63, 72. So I need 7 groups of 9s. 1, 2, 3, 4, 5, 6, 7. 63. Should have counted by 7s, because at least I could have done that one too. Now 6 times 7, or sorry, 8 times 8, 8, 16, 24, 32, 40, 48, 56, 64. 1, 2, 3, 4, 5, 6, 7, 8, 64. Next, 6 times 7. 7, 14, 21, 28, 35. Oh, I already did it up there. 42. So 42. Yeah, I could have just looked up here. Oh well. Next, now we're doing adding. That's way easier. Thank God for number 10. 3 times 5 is 8. 8 plus 7 is 15. 4 plus 6 is 10. 10 plus 7 is 17. 8 plus 2 is 10. Plus 9 equals 19. So in this one, actually, if we were in class, I'd be talking to you guys about things called compatible numbers. And I would be looking for any number that makes 10 or 20, any number ending in a 0 or a 5, because those are easier to add up from. So in this case, in this one, I didn't do that. 3 and 7 do make 10. So I could have just said 3 and 7 is 10 plus 5 is 15. But I also knew that 5 plus 3 is 8. But mathematically, it would have been probably easier for me to do 10 plus 5 is 15. But either way, they're both right. So it's up to you guys. All right, we're done with that one.